starting today. So I get to start with, what page are we on? Because I don't know the page numbers. I'm sorry.
Page 261, 262.
Okay, 262. We should be on example 11-ish. Okay, so
yeah, I'm gonna 11. I'm sorry, I made it through 10, not 9 yesterday.
No, that's fine. No worries.
I couldn't resist.
No, that's okay. Trig is fun. I can't ever stop doing it. So, you know what they say? It's not a day that ends in Y unless you've done some trig. So, all right, you guys should be seeing my screen. Is that right, Miss Rondeau?
Yes, we see your screen.
Hey, you know who's not here yet? Where's Brody? I don't see Brody in there.
Brody has
whatever.
He has an AP Euro exam.
Oh, okay.
That's too bad.
We're competing with AP Euro. See, I would really be winning if AP Euro wasn't going right now.
Oh, no. See, maybe that's where all my students are, too.
That might be it. That might be it. Okay, I did hit record. I'm now presenting to everyone, and lots of crazy stuff is coming up. Okay, here we go. I am starting with example 11. All right, so you guys talked yesterday. We're supposed to be using trigonometric identities to transform one side of the equation into the other. We're only staying in quadrant 1 for our answers, it looks like. So here's kind of the cool and fun part about trig. We spent most of the year learning algebra. So we did algebra, the algebra 2 level stuff. We're going to now combine trig and algebra together, because in this first one, we are going to FOIL it, okay? And if you remember the shortcuts, you're going to notice that these guys are conjugates. Hopefully you remember that word, conjugates. I don't know if I spelled it right. I sometimes mix up the J and the G. So when they're conjugates of each other, we know that the O and the I we don't have to use. We can just kind of shortcut it and do F and L. When we are doing this problem, though, we want to make sure they gave us the answer to the problem. We just have to do the work in between and show how we get a 1 out of this. So that's what my goal is on this problem. So I'm going to do secant times secant, which is secant squared theta. Okay. And then I'm going to do the back part. Tangent times negative tangent would be negative tangent squared theta. And you'll notice I'm writing my squared in kind of a funny spot. You have to be careful of that. Because if you wrote it out here, that means you're squaring the theta where instead of squaring the secant. Another way you can write it, so this is a no-no. Another way you can write it is put parentheses on the outside. So if you're super cool, you write the squared on the trig function. If you're a little less cool, it's still correct. You can write it on the outside of the parentheses. I'm super cool too. Yeah, I always write it on top of the trig function. There are times though, you guys, that it's necessary to understand that you have to put it out there. In calculus, we do have to move it around a little bit. So you gotta just be aware of that. All right, so Miss Rondeau, you went through the identities yesterday a little bit, didn't you?
Yes, we did.
Okay, so this one here, we need actually one of our Pythagorean identities. And we need to decide which one we're going to plug in. So anytime I see a squared, I think about those Pythagorean identities. When we're in our classrooms, they're pink and on the wall. So I call it's the pink Pythagorean identities. But I'm going to scroll back up here. Oh, I don't have them written out. That's nice. Okay. So let me look at that real quick. It's me. Sine squared, cos, and I know I'm missing my thetas. Tangent squared, secant squared, and cotangent squared and cosecant squared. Okay, you'll notice in those identities that things pair really well with each other. You'll keep seeing those patterns in calculus, okay? But this is the one we want. It's already solved for secant squared, so I'm going to replace secant squared in the problem we're doing with 1 plus tangent squared. And whatever angle they give us, the angle is kind of like a dummy variable. Any variable could get plopped in there. I'm going too fast. So I want to make sure I finish for Miss Rondeau's exciting part of the lesson today. All right, let's see. I'm going back to my, okay. So it's 1 plus tangent squared theta minus tangent squared theta. All right, and the idea was to verify and make sure we could get that 1. So now that I'm looking at that, and I substituted in that equivalent statement for secant squared, I can see that tangent squared minus tangent squared, those would cancel, and I'm just left with 1. And so I got back to exactly what I wanted right there. And when we grade something like this, not that we're grading this on you guys, but when we grade something like this, what we're looking for is that work in between. All right, so that takes us to example 12. Okay. I am going to use the trig identities to transform one side to the other again. So there's a couple of ways that I could do this one. I'm looking at what I did before. I am going to choose, it doesn't really matter what side you start with. It looks like I'm going to choose, I've done it this way before, so I'm going to choose that left side, even though it looks simpler. Sometimes I choose the more complicated side and try to get it manipulated. And trig is just all about manipulating it to get it to look like something else. So I know that cotangent, back from what we wrote down yesterday, and we've talked about for a couple days, is the cosine over the sine. And you'll notice that I wrote a squared. So if there's a squared on it, I write a squared. If there's a cubed on it, I write a cubed. If there's a 100 power on it, I write 100 power on it. Okay. All right. So I've done that part. And again, I'm trying to get the left side to look like the right side. So I'm going to keep going. That isn't what I want. But I did get this sine squared to appear. So what I want to do is I want to try to work with the cosine squared and see if I can replace the cosine squared with something that might get me closer to what the answer is that we want. I know that if I go up to my identities, I'm going to scroll up, sorry, and keep scrolling, okay, that I could work with this one here. And if we were in our classroom and we were looking at the pink Pythagorean identities, these would be all solved for you. But I'm going to try to replace cosine. So I'm going to take this sine and move it to the other side of the equation. So it's really cosine squared of whatever our variable is, theta, is 1 minus sine squared of the variable. These are equivalent equations. So I'm going to go ahead and replace that 1 minus, or that cosine squared with 1 minus sine squared and see if that gets me anywhere. With trig, you just kind of got to try stuff and see if it gets us anywhere. And the more you do, the more experience you get at it, the better you get at deciding what replaces what. All right, I'm getting a little bit closer. I'm not quite there yet. I need a sine squared in the denominator, but I have this crazy just 1 with no denominator. So I'm going to use an algebra property where I am allowed to write each of these numerators over the common denominator. So I've got 1 minus sine squared theta minus sine squared theta over sine squared theta. Okay. Well, I have this part. This part's checked off. I've got that matching. Okay. I need to reduce this, and that doesn't look like a very good squared. It looks like 2 theta, doesn't it? I'm going to fix that because that's super important. That's right. Okay. So I noticed that I have sine squared theta over sine squared theta, and a number over itself is just 1. So I've got 1 over sine squared theta minus 1, and now we match exactly. So we've got that verified. All right. How are we doing? Any comments or concerns in the chat, Ms. Rondeau?
No, I just put a comment in the chat about what conjugates were to clarify. Okay. I don't know that I did a very good articulate job of saying what they were, but we're good.
Okay.
No one asked. Right. I just put it in there. Just
no one asked. I know mine would have at least jogged their memory. So, all right, we're gonna skip all the calculator stuff. I'm not super worried about it for you guys for next year, and I'm gonna try to not assign any of it. I am going to take a slightly different approach with example 16 and 17 that I've probably done in the past. This has been a real weak spot for my calculus students this year. We're going to do more lessons on it. More of this comes up later. But we're now going to try to find the angle measure. So what we're doing is actually an inverse trig, which it doesn't explicitly come up in this lesson, but I'm going to teach it like it does because I think it's super important here. So in order to reverse anything, so if we've got x squared and we've got to solve that, we know we had to undo it, we have to take a square root, okay? If we're adding something to one side, or if I have that and I got to get it to the other side, I know I've got to subtract it to the other side. So I'm constantly doing opposites in math, in algebra, to get to solve for the variable. Well, I have to have an opposite operation of some kind to undo the cosine. We just came out of logarithms. We know that when we have natural log and e, those kind of reverse each other. So it's kind of along those same lines. What it's called is an inverse. And the way we write it, there's actually 2 ways to write it. So if I'm using cosine, I could do cosine inverse, or an equivalent thing, and you got to know both actually, is called arc cosine. So either one of those will work, and each one of the trig identity or trig functions has this. So we've got sine inverse, cosine inverse, tangent inverse. So if you see any of them, you can use that same notation. So I'm going to rewrite out. Go ahead.
I'm just going to bring up that most, if not all, the students should have seen the inverse version in geometry. We
Okay.
did do inverses in geometry. We do not talk about the arc versions like arc sine, arc cosine in geometry. So they at least have that if they remember. They did see it in geometry.
And I know that it's going to come up in another later lesson. It's popped in here. So, and I know that this is was a sticking point last year, and so I want to make sure it's done super well right now. So in order to undo that cosine and get the angle by itself, what I do is I take the cosine inverse of both sides. Okay. So that means that these two would cancel, and I'm just left with theta. And I need to find the cosine inverse of 1/2. Well, what that means is they just gave me the legs of my right triangle, and I have to figure out what angle they belong to. So I'm going to draw that right triangle. You're only probably going to see this happen with your 30, 60, 90 and your 45, 45, 90. So I've got my 30, 60, 90, and I know that this one is 1, 2 on the hypotenuse and square root of 3 there. And if you don't remember, go grab the picture of the unit circle where we have all those triangles there. Okay, so I am looking at what I have. I have that if it's cosine, I have the 1 and I have the 2. Okay, so if it's cosine, I know that the 1 has to be the adjacent leg and that the 2 has to be the hypotenuse. So that means if this is the adjacent leg, I would have to use this 60-degree reference angle, which means that theta is equal to 60 degrees. Is there anything else I'm missing, Ms. Rondeau?
I would just also add in that it's what it is in radians. That's it.
We were supposed to do both not the degrees and the radians according to the instructions. Did you guys do the conversions yesterday or not yet? Oh, we did that a couple days ago, right?
Yeah, we did. We did.
Okay. Yeah. So if you don't remember how to do it, remember you multiply by pi over 180, and that'll convert your degrees to radians. Or right now you do have your unit circles. You could just look on the unit circle at the degrees and the radians. Okay.
Mrs. Ballard, we also talked about in that problem in the directions how it has the ranges for what theta can be. We briefly talked about that. I believe it was yesterday. What that means that we're in quadrant 1.
Yes. So yeah, we're only doing quadrant 1 values for these particular problems. All right. I do need to, so I'm gonna do the same thing on this one. This one's a little bit different though. If I think about my triangles, I know I've got a triangle. I have the 30, 60, 90 triangle that looks like what I have over here on the left. I'm gonna draw my 45, 45, 90 triangle just so you guys can see it. And there is another way to do that. We're gonna teach this another way later on, okay? But I'm trying to base it off the triangle since we're doing right triangles today. These are 1s, and this is a square root of 2. So in this triangle, which is what this one is going to relate to, you'll notice there is no 2 in that triangle to relate it to. So what I'm going to do is something really bizarre, but I'm going to unrationalize it right now. Okay. So sine theta equals, and so I've got square root of 2 times square root of 2, which is 2. Over 2 square root of 2, and then my 2's are going to cancel. So I've got 1 over square root of 2. Now, and I should have left myself a little bit more space there because I'm going to write it on the top of that. So I've got 1 over square root of 2. Now I'm going to do this reverse the sine thing that we just did before. So I'm going to take the arc sine or the sine inverse of both sides. Okay. And I'm going to, that means that these two, a sine and a sine inverse, cancel each other out because they're inverses of each other. And then it means I need to use my triangle, or eventually we'll use our unit circle to do it, to figure out which angle measure this is relating to. So I know that I'm looking at a 1 and a square root of 2, and it doesn't matter which one I pick, okay, because the answer should come out the same. I know that my 1 is on the opposite leg, so this has to be opposite, and that the square root of 2 is on the hypotenuse. So this is, that way I would have to pick, if it's opposite, I have to pick that reference angle right there. So my theta has got to be 45 degrees. And then we know based on unit circle that 45 degrees is the same as pi over 4, or we could multiply by 180, pi over 180 to get there. Did I miss anything, Ms. Rondeau? Am I still doing okay?
I think you're doing great. The only thing maybe, and this is just for your notes, is the where you put the O for opposite on that 45, 45, 90 looks like a 0 for 10. I don't know if it's important.
At least it's a different color, right?
Right. Is it? It doesn't look very different.
It is.
Sorry.
It's a kind of a magenta-y purple versus
there you go. That's better. It's
right.
not that was nitpicking.
It was, but that's okay. I'm good with the nitpicking. All right.
You're good.
So I'm going to redo I don't see the, interesting. Okay. So there's a slide that I had in the slideshow where just kind of just refresh your memory. But it's not, of course, on the note page. So, and I'm just working from the note page. I'm going to refresh your memory on 30, 60, 90s, and 45, 45, 90s. I'm going to give you a different perspective. Miss Rondeau taught it beautifully the other day. But I'm going to look at it in a slightly different manner. I tend to be very formulaic, so I like following formulas. So I'm going to show this to you with formulas. You can do it Miss Rondeau's way. And this is the baby bears and the
Zach and Cody.
And Zach and Cody, okay? But I'm going to show you the way that I usually approach this, okay? So just set them on that box out there. Okay. Ellie's my daughter's interrupting my class right now. She just finished a super exciting big project. So, all right. Oh, so shh, quiet. All right. And I've got my 30, 60. I'm sorry, I'm redrawing. Okay. So the way I like to think about this, and again, you can use Big Mama Bear and Baby Bear, and you can use Zach and Cody, but I'm going to do this a little differently. So hypotenuse equals the short times 2. And the long equals the short times square root of 3. So that's for the 30, 60, 90. And I probably did not give myself enough space. So on all of our triangles, there's a long leg and a short leg and a hypotenuse. We know that this one's definitely the hypotenuse. My short is always across from the 30, and my long is always across from the 60. So depending upon which parts I have, I can use these formulas to find them. If I'm given the short, it's nice and easy. Sometimes I have to solve for the short. In the other triangle, let me use a different color, I only have one formula. It's that the hypotenuse equals the leg times square root of 2. And the way I keep them straight in my brain is that the one with the 30, 60, 90 is the one that has the 3 in it, the square root of 3 in it, and then the one that has the square root of 2 in it has the square root of 2. So that's kind of how I keep it straight. Zach and Cody might be better. I don't know. I didn't really watch Zach and Cody, so I'm slightly older than Miss Rondeau. So.
Well, they're doing the same thing. So just to assure anyone that it's just a phrasing thing. They're doing the exact same thing.
Yep, we're doing it's the same idea. It's just I'm just being a little bit more formulaic.
I found my history textbook.
Oh, good. Now you can do your social studies homework, Ellie. Thank you for
Yay.
Okay.
Yay.
She's super excited about finding your social studies textbook.
Back to
Shh, quiet. All right. So I'm going to start with what I'm given in example 18 here. I am given the long leg. So I need to figure out, I know that y is across from my 30, so that has to be the short leg. And I know that always across from my 90 is my hypotenuse. So I'm going to use the long leg formula to solve for the short leg first. So I'm using this one. So I'm putting in 100 for the long leg. I'm going to put in y for the short leg, and then I'm going to put in square root of 3. And I'm going to go ahead and divide by square root of 3. So 100 divided by square root of 3. And then I'm going to multiply top and bottom by that square root of 3. So we get 100 square root of 3 over 3. Because again, we don't like that radical in the denominator. I'm going to go equals. All right. Then I've got to find my hypotenuse. So I'm going to use, now that I know that this is the short leg, I'm going to use this formula here for the hypotenuse. So I know that my hypotenuse, which right now has an R on it, equals my new value for my short leg, 100 square root of 3 over 3, times the times 2 for the short leg, or 200 square root of 3 over 3. All right, I'm going to do this again for this other triangle. Oh, look at how exciting. We've got radicals on this triangle. That's the good news is, though, it's a 45, 45, 90 right triangle. And we know that those two sides are congruent, so we kind of get x for free. So we get x is 2 square root of 3. And then the hypotenuse, okay, so we only have one thing as for hypotenuse. So my r is the hypotenuse, equals a leg, and any either one of these, and I didn't mention that before, is the leg. So 2 square root of 3, and then times a square root of 2. And when you're multiplying radicals, remember insides with insides, outsides with outsides. So my 2 stays on the outside. 3 times 2 on the inside would be 6. I can't simplify that in any way, so that's done. Any questions, comments, concerns from the peanut gallery, Mrs. Rondeau?
No, I think we are good.
Okay. We're going to do, I get to do 3 more, and then we get to have Andy tell a joke. So everybody should be looking forward to that.
Great.
And the better thing about these 3 is you guys get to watch me draw. Miss Rondeau gives me the ones where I have to draw the pictures. So.
What, you found my evil plan.
I know. So it's because I'm a fabulous artist. Just watch. Okay. And I'm sure Madison's on for 5 more minutes, so she can watch my art stuff.
She gets to see the art.
I know.
Madison, don't be jealous.
Already see the art.
Oh, good Lord.
All right. I should have Madison do this part of the lesson. She wasn't going to take a test in 5 minutes. I would. All right. So a surveyor is standing 50 feet from the base of the large tree. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? Okay, so we need a surveyor. There we go. And we need a tree. Okay. Oh, I don't have brown, but I have black. So we'll use black for the trunk, and we'll make it even pretty now that I have pretty colors. All right.
Hashtag not boring.
Not boring. Not yet, at least. Okay, to the top of the tree. So you can see that I do have a right triangle there. And again, it's all about finding that right triangle. It said that we had an angle of elevation, and we did talk about that last week, where an angle of elevation is something that where we go up, and it is 71.5 degrees for the angle of elevation. A surveyor standing 50 feet from the base. So we know that the bottom of the tree is 50. We have our right angle in there. We are supposed to be figuring out how tall the tree is. So that's where I'm going to put my variable, and you can choose any variable you want. I don't recommend I, and I don't recommend E, but anything else is great. I do need to figure out which trig ratio I have, so we are going back to good old our friend SOHCAHTOA. And so I'm going to go that we know that we have this reference angle here, so this is the opposite, and we have the adjacent because there's nothing on my hypotenuse. So I know opposite and adjacent is tangent. So I'm going to say the tangent of 71.5 equals the opposite x over the adjacent 50. Okay. And in the interest of time, I'm not going to do the calculator work. I'm just going to tell you what the answer is because we've shown you how to do this a couple times in the calculator. But I'm going to move the 50 to the other side by multiplying both sides by 50. So I have 50 times the tangent of 71.5 equals x. And then when I do the buttons on my calculator, and when you do this in your calculator, you need to make sure it's in degree mode. We talked about modes the other day. If you're using Desmos, remember you have to switch it from radian to degrees. When I hit those buttons, I get 149.434, and then you want to label it, since it was a word problem, in feet. Okay. In that one, it doesn't matter that we have the goofy decimal point. If we were trying to go to Home Depot and get a ladder, we would probably round because they wouldn't sell one that's 0.434 feet long. All right, we're going to keep going. Is Madison impressed with my pictures yet?
Oh, absolutely.
Oh, thank you. Okay, you're making me feel good. Madison,
I wish I could draw that well.
You wish you could draw that. All right, we're 200 yards from a river. Oh, great, we get to draw a river. Okay, here goes. That river is purple. I needed a blue river. Oh, what happened? My drawing tools went away. Okay, here we go.
Special river.
It's raging with rapids there. Okay, there's my blue river. All right. You are 200 yards. Okay, so you got to draw a self-portrait. Okay, so here's Mrs. Ballard. A little bit of hair there. Okay. There we go. That's the pandemic, haircut that I haven't had my hair cut in forever. All right, that's okay. It's the coloring, not the cut, that I'm worried about right now. Okay. Although I'm lucky I don't have gray yet. So, okay. So there's my right triangle that I've kind of created. It says rather than walking directly to the river, you walk 400 yards along a straight path. So what that means is we're not walking this direction, we're walking this direction. So that's where my 400 goes. And you find the acute angle between this path and the river's edge. So what they're really wanting us to do is, there was something else that I missed. You are 200 yards. I missed this part. So there's a 200 right there. Okay. And what they're wanting us to find is they want us to find what the reference angle is. So earlier in the lesson, we had talked about those reversing with an inverse. We're going to do that here. And we can, well, it's going to come out nice. You can hit these buttons in your calculator, even though I'm not going to show you there. It is possible to do that. So I'm going to look at the parts that I have. I have the hypotenuse and I have the adjacent. So I know when I do hypotenuse and adjacent, I'm in Ka, part of SOHCAHTOA. Madison, you need to go log into your test.
She's already saying goodbye.
Good. Bye, Madison. Good luck.
Bye, guys.
Good luck.
All right. The adjacent is, so adjacent hypotenuse is cosine. So cosine of this angle theta, it's always the angle measure in there, equals 200 over 400. All right, well, I'm going to reduce that because that's way too big of a number for me. 200 over 400 would be 1/2. And then I'm going to do my inverse thing that we learned earlier in the lesson. I'm going to take the cosine inverse of both sides. That's going to cancel over here and just be theta. And I literally, if you go to your calculator, there will be a button that says cosine inverse. It looks just like this. You type in the 1/2. When you hit that button, you will end up with 60 degrees. And in this case, it would be make more sense in degrees versus radians. Are we good, Ms. Rondeau? Are we okay not showing the calculator steps?
Absolutely. Yep. Just keep blasting through. You're good.
Yep. Okay. Last one that I get to do with you guys today. And then I'm going to let Ms. Rondeau take over. We found the length of C of the skateboard ramp. Oh, we get to draw a skateboard ramp. Awesome.
Woo!
Skateboard ramp. Oh, that was a terrible, terrible line. Okay. Skateboard ramp.
My lines are always perfect.
The skateboard, complete with the skateboarder on it, right? And let's see, here's the skateboarder. We have to have a skateboarder, and skateboarders always wear a hat, right? So there we go. Okay. There's my skateboarder, and my son is laughing at my drawings. Okay, I'd like to see him try. All right, so find the length C of the skateboard ramp. So the skateboard ramp is C with a height of 4 feet and an angle of elevation. So my angle up is 18.4 degrees. All right, so again, I'm looking at the parts that I have and that I need. I have an opposite and I have a hypotenuse, and I know that that is the SO part of SOHCAHTOA. So I'm going to write that I have the sine of 18.4 equals the opposite 4 over the C. So this is the one where the variable's in the denominator. I'm going to multiply both sides by that C. I don't always show that step, but because we are distance learning right now, we're going to show that step. Okay. And then
You don't want to do the love connection? I'm teasing.
I don't do the love connection. All right. So you guys can do the love connection if you wish. All right. And then I'm going to divide by this ugly number here. It's just an ugly number. It just looks funny. 4 divided by sine of 18.4. And again, you could use your calculators. If you're using Desmos, make sure you just watch. Make sure you put parentheses around things. We end up with 12.672 feet. All right, I'm going to flip this up. I'm going to stop sharing my screen. We're going to let Andy tell his joke. Okay. Let me find the right place. There we go. Okay. I'm going to stop presenting. Okay, Andy, joke number 2 for the day to make up for yesterday.
Okay. What do you call a number that never stands still?
What do you call a number that never stands still? I don't know. What do you call a number that never stands still?
A Roman numeral.
Oh, a Roman numeral.
Wow.
That's really good because we talked about Roman numerals the other day, Andy. Thank you for doing that for us.
You're welcome.
Wow.
Summer's asking, do we need the summaries? Of course we need the summaries.
Summaries.
Right, Miss Rondeau?
Sure. Yes.
All right. I'm going to let Miss
Absolutely.
Rondeau go ahead and take it away.
Yay.
Fantastic. Okay, so I'm gonna steal the screen here. So we are jumping into the beginning of the next lesson. It's kind of long, so we're starting it today and we'll wrap it up tomorrow. So that would be page 264 in your notebooks. And sorry, just get this up.
No, you need to go.
And can we verify that you guys see my PowerPoint there?
Yes, I can see your PowerPoint.
Fantastic. So page 264 from the notebook. We're looking at trigonometric functions of any angle. Fantastic. So this is actually this first screen and the first thing in your notes. It's very, very similar to what we did. The days all run together. A couple days ago, maybe the end of last week, you guys talked about, I think it was actually Friday when I wasn't with you. You talked about unit circle and the fact that on the unit circle, the radius is always 1. So this picture is the same basic concept, except now we're saying, well, given a radius that could be any number, here are all of our trig functions in reference to that r being not 1, but whatever number the radius might be. So instead of sine being just y, if you have a different radius on your circle, if I look at my little triangle here with my reference angle, the sine would be opposite, which is your y value, over hypotenuse, which is your radius. So there you can see the y over r, kind of where that comes from. The y is the opposite and the r is your hypotenuse. And so if you do that with all of those, you would end up getting all of those different ratios. And you have them there for reference, so I'm just going to scoot past that. And then we're going to look at this. So practicing that concept. Again, anytime you have an angle, your reference angle is the angle drawn to the x-axis. The acute angle, I should say. And we're always going to draw our triangle with an altitude down to the x-axis. And we're finding all 6 trig functions. Given my ordered pair of -3, 4, that tells me I went over 3 units, but specifically on the graph, that was going back 3. Again, using my x value there, and then the y value of 4, I went up 4. There's your x and your y. And then the only thing I'm missing there is what that radius would have to be. And we haven't used the chat yet today, so help me out. What should my radius be? Type it in the chat.
All right, everybody in the chat, what should the radius be?
And it gave me time to drink some coffee.
I haven't even gotten that far yet, Miss Rondeau.
Oh,
After
no.
I drink coffee. I had hot chocolate, and that's it so far today. Uh-oh. Sorry. Andy snuck in there and is making weird things.
Oh, no.
Go do your work. All right. Let's see. I don't have anything in the chat yet.
Nobody knows.
Nobody.
Andy know?
Andy, do you know what the hypotenuse is supposed to be?
No.
Oh, good job. How did you get that?
What?
Use the Pythagorean theorem.
Okay, I gotta go.
All right. So, Ms. Rondeau, I believe you have to use the Pythagorean theorem to get that if you don't understand that that's a Pythagorean triple.
Yes, that's perfect. So this is one of our special Pythagorean triples. It's a 3, 4, 5 triangle. Or if you weren't sure, you could absolutely do the -3 squared, or you could just do 3 squared because it's the length of the side, plus 4 squared equals, and that would have been r squared. If you solve that, that would give you 5 for your r. All right, so now I have all the sides of my triangle. I'm going to go through and do my 6 trig functions. So this should be a lot of review. If I start with sine theta, using good old SOHCAHTOA, I have opposite over hypotenuse, or using our the chart that we just looked at, this guy, we know sine theta is going to be y over r. So that's going to be kind of our bent here is to do more of the coordinate plane. So y over r would be 4 over 5. And then cosine we know goes, hopefully we know it goes with x, adjacent over hypotenuse, or in this case, x over r. And then tangent, this one is going to be y over x, sine over cosine, opposite over adjacent, lots of different ways to talk about tangent. But for this one, we'll do y over x. Again, all of those would give you, all the ways that I mentioned would give you the same answer. We're doing all 6, so all the reciprocals, cosecants, would be 5 over 4, secant 5 over -3, and cotangent -3 over 4. All right, so we're going to move right through. That should be mostly review, just looking at the triangle on the graph. This time they don't give us the picture, they don't give us the graph. We have to create it ourselves. So we have to do this really, really challenging problem of putting the point 2, wow, look at my drawing, that's horrible. 2, -3 on a graph, that's a little better. So back to pre-algebra, going through and being able to put 2, -3 on the graph. I'm going to go over 2 and down 1, 2, 3. That gives me a point here-ish. So that's the point 2, -3. We're supposed to find all 6 trig functions for that angle that's created if this is our terminal side going through that point. So that means my angle is being measured all the way around here, but the reference angle always is the acute angle to the x-axis. So here's my picture. I know across my x was 2. I know my y was -3. Then I need my hypotenuse or my radius in this case. And this time it's not a special triangle, so we are going to practice Pythagorean theorem. Make sure when you do this that you use for your r or your hypotenuse, that is the equals c squared part of Pythagorean theorem. So I'm going to do r squared, and I get 4 plus 9 equals r squared. 13 is r squared and square root both sides. So square root of 13 does not simplify. Notice here I didn't do plus or minus either. When we do triangles on the unit circle or triangle, not unit circle, triangles on the graph like this, the radius will always be positive, always representing the distance from 0 to the point on the graph. And the distance is always going to be measured positively. The other numbers that we have, like the 2 and the -3, remember that negative comes from the location on the graph, not the distance. So just be careful with that. The radius will always be positive. All right, so then my trig functions, I have sine of theta is going to be y over r, which was root 13. And if I fix that up, just quickly without showing my work, I would do that version. Then I have cosine. That would be x over r. And again, I'm going to have to fix it up. So 2 root 13 over 13. And tangent y over x. So I have -3 over 2. Go through and flip them. Cosecant. You can flip the answer, or you can go back to the original. I'm going to go back to that first one again because that one's going to be a lot easier to flip. So root 13 over -3. I shouldn't say it's easier. It's just you don't have to rationalize it if you do that one. Then we have not cosine again. Sorry, got carried away. Apparently, I really like cosine. It's actually not true. For my students that had me before, does anyone remember what my favorite trig function is? Kind of random.
That could be all of them. They almost all had you before.
They did, but do they remember?
I even know your favorite trig function. Is cosine or is sine the reciprocal of cosine as well?
No, I'm just typing in whatever.
I have an inkling though that sine might be your favorite trig function.
I just write in whatever I want. Okay, sorry. Yes, the reciprocal.
No one in the chat has guessed.
That's okay. It's not a big deal. If they do, though, let me know.
I will. I'm totally curious. So.
All right. So there we go. I made it through, I think, the last one. And there we go. Any questions, concerns? How are we doing, Mrs. Ballard?
We're doing good. There was one in the chat. You covered it, and I covered it in the chat about the negatives. So we're good.
Okay, good. Fantastic. Okay. Any guesses as to my favorite trig function?
No, they're kind of sleepy today.
Wow. All right. Then the next part here, you have this separated into 2 blocks in your notebook. In the notebook version, sorry about that. They're 2 separate blocks, and they're side by side. The main point of this is really about something you guys went over last week, and that is that all students take calculus. We're going to be using that in the next several examples. So just a reminder about what that means. If you're like, what are they talking about? All students take calculus. The A stands for all trig functions are positive in quadrant 1. Then the S stands for sine, but also cosecant, because those are reciprocals, are positive in quadrant 2. The T stands for tangent, but also cotangent, are positive in quadrant 3. And then the last one is cosine and secant are positive in quadrant 4. So just a reminder, because that's super, we're gonna do examples that have to do with this. And so just a refresher there. The bottom one, which is gonna be on the right-hand side in your notebook, this one gives you some of those markers for how we define our quadrants a little bit. When you see these pop up in directions, they're telling you what quadrant you're in radians. So if you forget, you can come back and check. And it also gives you whether X is positive or negative and Y is positive or negative. So just for reference, here we go. On to, this should be on the next page, on page 265. State the quadrant in which theta lies. So here we are told that sine of theta is greater than 0. If sine is greater than 0, what kind of number, if I calculated it out, if I knew everything about it, what kind of number is greater than 0?
Okay, everybody put that in the chat. We want to see this in the chat. So if a number is greater than 0, what does that really mean about the number?
See, the chat is really about my coffee breaks. I need a drink of coffee.
That's funny. Yeah.
Chat's really quiet today, or everyone's interconnect connection's super slow. Oh, we got something. 2 people said it's positive. One of yours, one of mine. So they are listening.
Good. All right. Awesome. So yes, if sine theta is greater than 0, it means it's positive. And reversely, if cosine theta is less than 0, it means it's negative. So if I grab all students.
Is reversely a new word, Miss Rondeau?
Yes. I just make up stuff right and left. Just ask my students. I just say whatever I want.
It might be, is it conversely? I don't know. I don't know my geometry that well anymore.
I honestly, I don't remember. I knew it once upon a time. I think it's conversely. I think that's it. Because it's not the contrapositive and it's not the inverse. Oh, yeah. No, it is the inverse.
It's inversely.
Inversely, yes. Okay, anyways.
It's something with a "ly" on the end.
Okay, the students have no idea what we're talking about because they didn't have to learn those words. Anyway, pretty funny. Okay, so we have
all those awful sentences. I had to do all those awful sentences.
Yeah, they didn't have to. Thank goodness. You really need that more for like later abstract algebra and stuff when you're proving things in a more complicated way. Okay, so we have all students take calculus representing where trig functions are positive. I need a quadrant where sine is positive, but cosine will be negative. So right off the bat, I'm going to check all. Are all my trig functions positive? No, because cosine has to be negative. Then I can narrow it down to I need sine to be positive and cosine negative. The only place where sine is positive besides quadrant 1 is in quadrant 2, and cosine will in fact be negative. So there's our quadrant 2. All right, on to the next one. Same kind of thing. This one though, we have secant. So all students take calculus is based on the original 3 trig functions. So I'm going to reference that secant goes with cosine. Remember, those are reciprocal buddies. So this is telling me that secant or cosine is negative. Tangent is positive. I'm going to go back to all students take calculus. And right off the bat, I eliminate quadrant 1 because I have a negative happening. And then I look for, all right, I need tangent to be positive. That's going to be quadrant 3. And in fact, secant and cosine will be negative there. So we're good. Any questions, concerns?
Think we're good, Miss Rondeau.
Fantastic.
Oh, we got more Roman numerals today. That was a good joke on Andy's part.
Yes, it was perfect.
We didn't even plan that.
Very nice. All right, so this one we're going to find the values of all the trig functions for theta. And we are told that theta is in quadrant 3, so I'm back to drawing my pictures. I love to draw pictures. Not real pictures like Mrs. Ballard, just, you know, like the graph. That's all I can handle.
Mine are fabulous, aren't they?
They are.
I did teach art for 2 years. Did you know that?
I did not know that.
I taught multimedia, which is technically an art class, for 2 years.
I did know that one, so I just didn't
I can't believe they let me do it.
All right, so we're told that theta is in quadrant 3. So that means my terminal side is over here in quadrant 3. And I'm going to draw, of course, my triangle back to the x-axis. So my theta is measured all the way to there. My reference angle is here. From that reference angle of theta, I have sine and I have some values. So once again, we have sine is opposite over hypotenuse, or as we learned today, this would be x and r. And that p is just driving me crazy. It's a little ridiculous. Okay, so if I go to my picture, I also have this negative. I'll get to the negative in a quick second. First, I'm going to just do opposite. Why did I write x? Mrs. Ballard, you just let me write x. Wow.
I'm sorry.
It's okay. The opposite
I was making a homework assignment. I apologize.
The opposite is definitely not x. Sine always goes with y. The opposite is y, and we can see that in our picture. Okay, so now I'm going to put my 2 here, and I'm going to put my radius of 3 here. And I know that the radius always has to be positive, so the negative is not going to go with both. It only goes with one or the other. If it went with both, you would have negative divided by negative, which is really a positive, and that's a no-no. Okay, so the negative is going to actually go with the 2, and you can see that based on the location on a graph, I would be going down 2 to get to that point on the terminal side. So again, it's not the length of the side, even though it is, it's the location on the graph. Okay, so that's sine. Then I'm missing my adjacent side, so I got to do some Pythagorean theorem, and I'm going to call this x. So I'm going to go x squared plus negative 2 squared equals 3 squared. I get x squared plus 4 equals 9. Subtract that 4. And I have x squared equals 5. Square root both sides. X equals square root of 5. And in this case, when I put it on my graph as square root of 5, I need to add in the negative because I'm going back square root of 5 again to get to that point on the terminal side. So because of the location on the graph, that actually has to be a negative square root of 5. Okay, now I have all my pieces, my x, my y, my r. Here goes, we already were given sine, but of course, like you guys saw yesterday, I just write it out anyways. Then cosine would be adjacent over hypotenuse. And tangent would be opposite over adjacent, or y over x. And this one, we're going to fix it up. First thing is negative divided by negative. That's going to give me a positive. And then as I rationalize it, I would get 2 root 5 over 5. Then all my reciprocals, cosecant theta, that's going to be r over y. Secant theta, I got secant right this time. 3.
Good job.
Yeah.
I still don't know what your favorite is, though, and nobody's guessed.
That's okay.
Are you sure you had these students last year?
Yeah, I might not have made a big deal about it because I try not to be biased against the other trig functions.
Oh, okay.
So that could be why. All right, so when I flip that one over, that's my r over x, and then I'm going to rationalize it. So 3 root 5 over 5, and don't forget that negative. I almost lost it. I didn't. It's there. And then cotangent, I'm going to go back and flip again the original one. And so I get root 5 over 2. My negatives, remember, negative divided by negative is a positive. So that finishes that one up. Any questions?
I don't have any, and they still are very, very quiet in the chat.
Okay. All right. Mrs. Ballard, how are we doing on time?
We have like 6 minutes left till 11.
All right. Well, this is perfect because this was the one I was trying to get through. So we're going to wrap it up with this one. All right. So what's that?
Yay!
Yay! All right, so once again, I'm going to be drawing my picture here, trying to figure out where to draw cosine theta. I am given cosine theta is 3/5, and then I'm told that tangent is less than 0. We just looked at this kind of idea before. If it's less than 0, that means it's negative. So if I go back to all students take calculus, I need a place where tangent is less than 0 or negative. So places tangent is positive, I'm going to cancel those out. So it's not quadrant 1 and it's not quadrant 3 because that's where tangent would be positive. Then I go back and look at cosine is 3/5. That's a positive value. So my choices are quadrant 2 or quadrant 4. It's got to be quadrant 4 because that's where cosine is going to be positive. So I'm going to draw my picture again. Here I am in quadrant 4. Always draw that altitude to the x-axis. Remember, the angle is being measured this way, but my reference is here. It's a horrible theta, but that's okay. And I'm going to label my sides. So for cosine, that's adjacent over hypotenuse. Or as we picked up today, that would be x over r. So x over r, my x is 3, my r is 5. And I'm set to go, except I still need my y value or my opposite. In this case, this would be a Pythagorean triple because I'm missing the number 4. So 3, 4, 5. But there is something else missing. I'm going to do one more quick chat question. What is missing from my picture? Specifically, what's missing from the 4?
All right, so in the chat, tell us what's missing from the 4. Oh, we got something. I'm seeing a negative sign.
Yes, I am missing a negative, even though the length of the side of the triangle would be a positive 4. The location is I go right 3 and down 4 to get to the point here, which would be 3, -4. So definitely, definitely keep in mind the location aspect, okay? All right, so we have sine of theta is y over r, so I have -4/5. Cosine they gave us. And tangent is going to be y over x, -4/3. Then I go through and flip them, and the flips are pretty easy on this one. 5 over -4. For cosecant, secant is 5/3, and then cotangent 3 over -4. And that's it. Any questions?
Do we have any questions or any concerns that you guys have? You can either come off your microphones or you can talk to us in the chat. While we are waiting, the last couple of things. So I made a homework assignment. I sent it to Miss Rondeau, so she's going to get it up. It's a web assign. I only made it on the first part of the notes today, the part that I finished. What we're going to do is we're going to finish the notes Rondeau started with you. Okay. Oh, we're getting there, Marilyn. We'll ask. Okay. All right. And then maybe she'll sing something for us. Who knows? We like to put on a good show. So I draw and she sings. All right. All right. So what we'll do is tomorrow we're going to give you like a bonus assignment. So we're going to give you something that covers what Ms. Rondeau taught from the middle of today and then and what we're going to teach tomorrow. So we'll give you a Thursday assignment and a Friday so you guys can earn double the points for instead of us giving you one giant assignment. I hope that sounds really good because I know you guys are super excited about doing homework. All right, Ms. Rondeau, what is your favorite trig function?
My favorite trig function is, as Mrs. Ballard suspected, sine. Sine
Why?
is the best one. I don't know why. It just, when I learned trig functions, the sine, cosine, and tangent way back in geometry, a long time ago, because I'm super old, we didn't talk about SOHCAHTOA. My teachers were not informed in the ways of SOHCAHTOA. And so I just had to figure out a way to make it make sense. And it was all centered around sine. I don't know why, but it's how my brain works. So sine is always my default. I'd rather do sine than anything else.
Awesome. Well, anytime we have a sign now, we know we're going to think of Mrs. Rondeau.
There you go.
It will be a sign because it's from Mrs. Rondeau.
I do want to comment too. Actually, this is more for Mrs. Ballard for a quick second. I don't believe that I posted a homework for yesterday for my students. If you will just make sure, Mrs. Ballard, to shoot it to me so I can put that up. And I will
thought I
upload.
did, but I'm sorry if I didn't. Yesterday was crazy. So.
That's right, Summer. 37, my favorite number, sign, and Christmas. They know me very well.
I don't think they know my favorite number.
Oh, I know what Mrs. Ballard's favorite number is, maybe.
Maybe?
The square root of 93?
Nope.
98.
98, yes. The square root of 98. I don't know why. It just speaks to me. So, because it's 7 root 2. So.
There you go.
I don't know. Just like Miss Rondeau doesn't know why hers is sign, and I don't have a favorite trig function. Maybe I'll come up with one before tomorrow.
Okay.
So.
I have a second favorite number too. Does anyone know what my second favorite number is?
What's the second favorite number?
I'll just tell it. It's 42.
42. Why is it 42?